Okay, stats. We are on the chapter 3 review. We're gonna do this review today. I'm gonna go through each one of these problems with you. Make sure that you're paying attention as you go through and you understand what's going on, because we're gonna test tomorrow over this chapter. Okay. This is a rather short review. I think it's gonna be okay. I will, how about this? I will let you use your review on your test, okay? So as we go through this, make sure you're writing stuff down, but make sure you understand what you're doing. It's coming. Okay, it's coming. Make sure you're paying attention to each problem as we go through and you understand how to do it, okay? It's coming, okay? All right, first one, box plot. Here's your data. It is in order already for you, so that is super nice, but they want the 5-number summary. 5-number summary is min, max, median. You just want mom, huh? Daddy's naughty. Okay.
Yeah.
All right. The minimum is 25. Max is 98. Not too bad. There are 40 numbers. All right, so if we're trying to find the median, 40 split in half is 20 here and 20 here. There will not be an exact middle number, but it will be the average of the 20th and the 21st number, okay? 20th number is this guy, 21st number is this guy. 72 and 72, if I average those together, that is 72, okay? Now, my first half of my data is going to get split like this, okay? So those 20 numbers, I'm going to use to find the Q1. 20 numbers would be the 10th and 11th number averaged together. So 57 and 59 is 58. And then I'm going to find the average of the second half of my data. So these last 20 numbers. And that would be between 81 and 81. And 81 plus 81 divided by 2 is 81. So that's my 5-number summary. And then they want a box and whisker plot. So I'm going to draw a ruler down here on the bottom first. And I'm going to go from, let's go like 20 to 100 maybe. Okay, and then right in the middle of that would be 60. And let's go in the middle of here, that would be 40, 80, 100. And there's that. Okay, I don't care how you want to do it, whatever you want to do. But here's my box and whisker plot. 25 is, I'm going to just put them there. That's my whisker. 98 is also one of those. And then my boxes go with these guys. So 58, right about there. 72, it's coming. And there we go. There's my box. Okay, box and whisker plot. There you are. All right. Okay, standard deviation. I will make you do one of these. That's the longhand way. Okay. And so there are only 5 numbers here. I think the one on the test maybe has 4 or 5 numbers, but I make you do it the longhand way. If you can remember how to do it on your calculator, that's handy because then you can check your answer, but I will expect you to do all the work for the longhand way. Okay. This is the second formula. The one that people liked the most, I guess. When you're doing that, it looks uglier than the first one, than the first formula, but it's actually a little bit nicer than the first formula. So I'm going to get my table ready to go. The table's a lot smaller. I have 5 rows, 1, 2, 3, 4, 5. Here is X, and then the other column that I need is X squared. Okay, so I'm going to put all my X's in here. I've got 7, I've got 2, I've got 5, no, I've got 7, 7, 2, 5, 1. Okay, and if I square them, I can do some of this in my head. I can do 49, 49, 4, 25, and 1 if I square each one of those. Okay, now I'm gonna do some sums here. I'm gonna add these up. Okay, so 7, 7, that's 14, 15, 16. 16 plus 6 is 22 if I add those up. Right, this is 98 plus 30 is 128 for that guy. Okay, now I'm going to plop that stuff into my equation here. So let's see what we've got. All right, I'm going to put him over to the side over here. The square root of, we've got n is this guy. N is the number of numbers that you have. So that would be 5. And then I've got the sum of all the x squared values. Okay, that would be, my x squared values are here, and the sum of those is 128. So that's this number here, minus the sum of all the x's, which is 22, that number squared, all over n, which we said was 5, times n minus 1, which will be 4. Okay? All right, I'm going to type that on my calculator all at one shot and see what I get. The square root, the square root of 5 times 128 minus 22 squared. What, honey? Okay, all right. Okay, and I got, for standard deviation, I got 2.79 abouts. Okay, standard deviation, that's what I got using that method. That wasn't too bad. That didn't take too long. Okay. So make sure you know how to use one of those formulas. I will give you the formula on the test, though, for standard deviation. So just make sure you know how to use it. Okay. All right, number 3. They want us to find P56, which is the 56th percentile. Okay, all right, when you're going from percentile to finding what number is the 56th percentile, you have to do it a certain way. Now, before we do that, I know that the 50th percentile is exactly in half, right? So like here, like 72 would be the 50th percentile, right? So the 56th percentile is going to be like one of these numbers maybe, right? A little bit higher than 50%, okay? So 56th percentile, here's what we do. We take 50% or whatever, we take that number and we 56, and we divide by 100, okay? That gives us 0.56, and then I'm going to multiply by the number of numbers that I have, right? Multiply by n. So since I have 40 numbers, 0.56 times 4d ends up being 22.4. 22.4, okay? So what I'm going to do is, because this is a decimal, I'm going to write out both scenarios. If it's a decimal, you round up. Okay, so 22.4 is going to round up to the 23rd number. Okay, so the 23rd number in my data set, this is number 20, right? 21, 22, 23. It is 74 is my number that I want, the 23rd number. Okay, now what if this number would have come out a whole number? You take the average of that number and the next. Okay, so for example, let's say this just came out as 22 total, right? If it was 22, I would take the 22nd and 23rd number and average them together. Yes, I hear. The 22nd is this guy, the 23rd is this guy. I would average those two together to get my percentile. Okay, so if it's a decimal, you round up and you take that number. If it's a whole number, you take that number and the next number and you average them together. Okay, so 74 is the correct answer for that guy. Woo! All right, next, Q3. These won't all take this long. Q3, I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. Okay, so I have to find my median first. Okay, median is going to be the middle, and the middle two numbers are there, right there. I don't know, the middle of 52 and 74, if I add those together. 52 plus 74 divided by 2 is 63. Okay, 63 is my median. Now what I'm going to do is, to find Q1, I would take and find the median of those four numbers. But to find Q3, I take the median of these four numbers, okay? Which means I'm going to have to average my middle two. So 67 and 55. 67 plus 55 divided by 2, and that is 61. So Q3 is 61. Okay, so there is that. If you have any questions, ask each other. You guys can help each other out, figure out what that is if you have questions on how to find Q3 or Q1 or anything like that, right? Okay, a student earned grades of 84, 78, 84, and 72 on her 4 regular tests. Okay, so what's going to happen is, before I move on, I have 4 tests that are going in, and we're going to find the average test grade. So I'm going to go TA for test average. I'm going to add those up together. So 84 plus 78 plus 84 plus 72. And I'm going to divide that by 4, and that's going to give me my test average. Lay down. What's the matter? Oh, I need to kiss it. You got an owie. Okay, all right. You lay down. 84 plus 78 plus 84 plus 72, and I divide by 4 is 79.5 if I do that. Okay, so that is my rate, my test average. All right, she earned a grade of a 78 on the final. So now I have my test grade is a 79.5. My final is a 78. 86 on her class project, and her homework grade was an 87. Okay, so they gave me the like average of all the other ones, of all these other ones, right? But then they gave me like individual test scores, so I just need to find the test average there, right, to be able to do those. Okay, now they're going to tell me what the weights are. So the 4 regular tests count for 40%. This is 40% or 0.4. The final exam is 30%, so 0.3. The project is 0.1 or 10%, and homework is 20%, so 0.2. Okay, so there is that, and I'm going to end up and multiply those together. Let's see, 79.5 times 0.4, and that is 31.8. 78 times 0.3, and that's 23.4. 86 times 0.1 is 8.6, and 87 times 0.2 is going to be 17.4. Okay, so there is that. Now I'm going to add those together. 31.8 plus 23.4 plus 8.6 plus 17.4 is 81.2. Okay. Oh, by the way, after you add these together, you do end up having to divide by something, but you're dividing by these added all up together. 0.4, 0.3, 0.1, 0.2. That's like dividing by 100% or dividing by 1, so it stays 81.2. So when you're finding the average, you're like adding and you're dividing by something, right? You're adding those up and you're dividing by 1 or 100%. So 81.2 is what you get, okay? Round a decimal, 1 decimal place, 81.2. There you go, okay? All right, next one is, I'm going to put it down over here. We got a B. We got a B. We got an A. We got a C. And we got a D. And those courses had credits that were 4, 5, 1, 5, 4. Okay? The problem is I can't take B times 4 and I can't take B times 5, right? So what I have to do is I have to use numbers instead of the A, B, C, D letters, right? So an A is worth 4, a B is worth 3, a C is worth 2, and a D is worth 1, and an F is worth 0, but I didn't get any Fs, right? Okay, so there's that. So now I'm going to end up multiplying those together. Okay, so like just like I did before, I'm going to multiply by the weights. So this is 12, 3 times 5 is 15, 4 times 1 is 4, 2 times 5 is 10, and 4 times 1 is 4 again, right? Then I'm going to add all of those numbers together. I'm going to use a calculator because my brain is just not with it. Okay, I got 45, okay? Now, this is the kicker. Which number do you divide by? Do you divide by all of these, which is your grades, or do you divide by the number of weights? We want to divide by the number of weights. Okay, those added together ends up being, I think, like 19. So I take 45 and I divide by 19, and I get something in the ballpark of 2.37. That is not a very good GPA. Okay, so their GPA is 2.37. Done. Okay, good, good. All right, human body temps have a mean that is 98.2. So I'm going to write that down. Mean is X bar, 98.2, and a standard deviation of 0.62. Sally's temperature can be described as a z-score of negative 1.5. Okay, negative 1.5. So she is 1.5 standard deviations below average. Okay, what is her temperature? So 98.2, just so we're clear, 98.2 is here, right? And she is 1.5 standard deviations below average, right? But 1 unit of standard deviation is 0.62. So it's like I've subtracted 0.62 and a half of a 0.62, which is subtracting 0.31, right? Okay. Another way you could do this is just take 0.62 and multiply negative 0.62 times 1. Actually, I'm just going to do positive 0.62. 0.62 times 1.5, and that's going to end up giving you 0.93, and that's how far you are, and you're going to end up subtracting 0.93 from the 98.2. 98.2 minus 0.93, okay, is 97.27. 97.27, okay? So the kicker there was that you need to know that z-score means how many units of standard deviation you are, right? So negative 1.5 is 1.5 of these lower than this, right? So you're just going to multiply by 1.5 and subtract it, right? Okay. Listed below are the amounts of time in months that an employee at a restaurant has been working at the restaurant. Find the mean. Oh, that's too easy. Find the mean. And round your answer to one more decimal place than the original values. Okay, the original values have no decimal place, so you're going to use 1 decimal place when you do this. I don't know. I'm not going to do 8 for you. You can do the mean. Can you do the mean? You can average those together. That's too easy. All right, next, number 9. They have the vehicles, the number of vehicles passing through a bank drive-up line each 15-minute period was recorded, okay? So there's 25 that showed up in the first 15 minutes, there was 28 that showed up in the next 15 minutes, etc. Find the median. Are these not in order? Crap. Find the median. These are not in order. The middle number, right? So, I don't know, how many numbers are there? 4 by 5, 20 numbers, right? Okay, so if we put them in order, okay, right, 15, and next would be 20, and I don't know, 24 maybe is the next one. I don't know, put them in order and find the median. You guys can do that. Can you do that? You can find mean, you can find median. Work together, figure out how to find the median and the median. You know how to do that. Okay, next, below find the range. Oh, these are too easy. Find the range. The highest minus the lowest. You can do that. Find the range. There you go, 8, 9, 10. You can do those on your own. Okay, the next one is finding the coefficient of variation, okay, for these two. All right, so the automated menu. So basically what we have going on here is an automated system doing like soliciting calls, or a live agent, like a live person sitting there on the phone soliciting calls, okay? And we're recording the amount of time each customer is given to answer. So sometimes the automated like person, whatever automated menu, takes longer to answer the questions versus the live agent, and sometimes it's the other way around, okay? So they're trying to figure out which one is better, which one people like the most, right? Okay, so find the coefficient of variation. Coefficient of variation, write this down, is the standard deviation divided by the average. I want to be able to compare these two, but if one of them has an average that's 20 and one of them has an average is 5, this standard deviation should end up being higher than this standard deviation, right? Because the average is higher versus lower. Yeah, what'd you do that for? Yeah? It's all right. Lay down, please. Come here. So we've got to find the average, the mean, and the standard deviation for each one, right? So average, standard deviation, average, standard deviation. Yeah, you're just something else right now. You're gonna sit. Okay. All right, you sit right here. All right, we gotta help her, guys.
What are you doing, Mom?
I'm trying to work. I'm doing work. Okay, so I'm putting these into my calculator. Let me go first set. 11.7. I would, if I were you, do this and figure out how to do this. Okay, so remember how to calculate standard deviation on the calculator. 3.9, 2.9, 9.2. Don't. 6.3 and 5.5. 1, 2, 3, 4, 5, 6, 7, I think. Yep. Okay. Stat, calc, one variable stats. You are fine. Oh boy, we're just having a rough go. 6.7 is my average, and 3.04 is the standard deviation. Okay. Second data set is you're just being dramatic. You are being so dramatic. Yeah, you're fine. 0.4, 4.1, 3.4, 5.2, and 3.7. Okay, stat, calc, one variable stats. Hey, Sister Bean, good heavens. Average, 4. Hey. 4.27. Goodness. And 1.13. Okay. Hey, listen, sister. Come here. Okay. Okay, so we're trying to figure out which one has more variation, right? Variation means like the data is more spread apart. So the deal here is this one looks like he has more variation because the standard deviation is higher, but his average is higher to begin with. So he should vary more because he has a higher mean to begin with. So we're going to figure out which one has a higher coefficient of variation, or which one's data varies more, all right? So we're going to take the standard deviation divided by the average, and we're going to take it times 100. Hey, you stop. 1.13 divided by 4.27 times 100. And we're going to get each one of those. Hey, that's enough. You're just being dramatic now. Yeah. Have kids, they said. It will be fun, they said. 43 or 45.37 is what I get for that one. Hey. I got 26.46. Okay, now here's the interesting results though. Okay, people like consistency. Consistency means that your variation is low, right? It's not varying a lot, so you have more consistent data. So a lot of people think, oh, let's make everything automated because then it's more consistent. But guess what's happening? Your variation is actually higher with an automated agent, right? So you're more consistent, and people are going to be less pissy with a live agent because they have more consistency, because 26.46 is a smaller variation, right? So let's answer the question. It says he records the time, compare the results. Round to one. Oh, I said round to one decimal place. Well, whatever. I rounded to 2. Okay. Compare the variation. So more variation with automated. Okay. More consistency with live agent. Yes, right, sister. Why not? Why not? Okay, last couple. These are all multiple choice kind of things, okay? So number 12, approximately what percent of apple diameters are greater than you if you are the 66th percentile? Well, 66th percentile means that 66% of people are lower than you. So what percentage is higher than you, right? 100 minus 66, which would end up being 34%. So 34% will end up being larger than your value if you are the 66th percentile. Okay, that's not too bad. All right, a couple more. If the standard deviation of a data set is 0, the standard deviation is 0. It means it is not deviating at all. Can you have a standard deviation that is 0? It means it's not deviating at all. We can have standard deviation of 0, like let's say if I have 5 numbers and they're all a 7, right? How much is that data set deviating, right? None. It's still got data, right? It's still, you know, a data set, but it has no deviation. So is it true that all of the data values are identical? Yeah, I think so. B, all of the data values are negative. Not necessarily. All of the data values equal 0. Not necessarily. And none of the above must be true since standard deviation cannot be equal to 0. You can have a standard deviation that's 0. It doesn't happen very often, but your data would all have to be exactly the same values. Okay? All right, this one. Here we go. Scores on the SAT have a mean. I'm going to do this over here. SAT and ACT. I like this question. Have an average of 15, 18, and a standard deviation of 325. And ACT has a mean of 21.1 and a standard deviation of 4.8. Okay, which of the following choice is not true? Okay, so we want to end up comparing a 17 ACT score. So I'm going to put that over here as X. X is a 17 and an SAT score of 1490. Okay, that's what a lot of these questions are dealing with, is those, all right? So here's what we're going to do. I want to compare SAT to ACT, but they're on 2 entirely different scales. So what I'm going to do is I'm going to find their Z-score, and Z is X minus X bar divided by the standard deviation, right? So, so X was that 1490 number, 1490 minus the 1518 divided by the standard deviation, 325, okay? Over here, if I do that same concept, I've got 17 minus 21.1 divided by the 4.8, okay? And let's see what we get for each one of those. You're all right. 1490 minus 1518 divided by 325. I got negative 0.09 if we rounded 2 decimal places. Okay, this one's 17 minus 21.1 divided by 4.8 is negative 0.85. Okay, that's what I got. All right, now let's put this on a number line right here, right? X bar is the average, all right? And each one of these numbers is a Z-score, and that tells me how many standard deviations I am above or below the average, right? Okay, so if SAT is negative 0.9, here's where one standard deviation below the average lives, right? 0.9 would be right here. This is where SAT lives, okay? 0.09, negative 0.09. Negative 0.85 would be over here. This is ACT at negative 0.85, right? It's more negative, okay? So when I'm looking here, let's see which one is better. This is an ACT score of 17.0, has a Z-score of negative 0.85. ACT of 17 has a Z-score of negative 0.85. That is true, okay? Which of the following choices is not true, though? An ACT score of 17 is better than 1490, okay? Is 17 better than 1490? Is ACT better than SAT? Is ACT better than SAT? SAT is on the right side of ACT, so that is not true, okay? Now, what's funny, though, is that this one is saying the exact opposite of that, right? 1490 is better than 17. So they're saying SAT is better than ACT. SAT is better than ACT. So C is true, right? And then D, SAT of 1490 has a z-score of negative 0.09. We found that, right? So that is true. So which of the following is not true? B is actually the correct answer for that, right? He's the only one that's not true. Now, really, technically, you knew that the answer had to be B or C because they are saying the opposite of each other, right? If B is saying one is better than the other and C is saying the opposite of that, one of those has to be true, right? So I don't even really have to look at A or D because I know one of B or C has to be the correct answer. All right, okay, last one. If your score on the next stats test is converted to a z-score, which one would you prefer to have? Okay, so if your average is here in the middle, your z-score tells you the number of standard deviations you are above or below average, okay? The z-score for the average is 0. That's 0 units above average, right? One standard deviation would have a z-score of 1. Two standard deviations would have a z-score of 2. One below would be at a -1 z-score. Two below would be a -2 z-score, etc., right? Which one would you rather have? I would rather have this one right here, the one that's all the way over, a 2 above, right? This is 2 below average. I don't want to be 2 below average. I don't want to be -1 below average. I don't want to be the average exactly. I don't want to be on 0. I want to be 2 units above average. That's what I want to be, okay? So there you go. Look this over, study anything that you are like, I have no idea what that was. Make sure you finish those last 3, and we will test tomorrow. Goodbye.